Ever order from Uber Eats late at night? And you wonder how they make sure your driver gets to the right place, grabs your order, gets to you while it's still hot.
Right.
That's what we're diving into today. The surprisingly complex tech that powers those everyday Uber moments. We're going behind the scenes
Yeah.
with a research paper called Real-Time Data Infrastructure at Uber. Now, this paper is about as exciting to read as your average tax form.
Sure.
But don't worry, that's what we're here for. We'll break down the technical jargon and uncover how Uber uses data to do everything from calculating surge pricing to making sure your Uber Eats order doesn't get lost in the digital shuffle.
What's mind-blowing is the sheer volume of information Uber deals with. We're talking trillions of messages every single day. Rider requests, driver locations, restaurant menus, updated order statuses. It's a constant flood of data from around the world.
It's trillions. I
Trillions.
can barely manage the notifications on my phone. Yeah. But here's what gets me. Uber can't afford to just sit back and process this information slowly. It all has to be analyzed instantly to make sure you get matched with the closest driver, your fare is calculated correctly, and your late-night snack gets delivered on time. That's a tall order.
Absolutely. And to manage this data deluge, Uber turned to a tool called Apache Kafka. Imagine a massive, super efficient digital postal service that never sleeps.
Okay.
That's Kafka. It receives those trillions of messages, sorts them, and makes sure they get delivered to the right place at lightning speed. What's fascinating is that Kafka wasn't originally designed for this kind of heavy lifting. It was built to handle logs, those records of what's happening on a computer system.
So Uber took a tool designed for basically tracking computer activity and turned it into the backbone of their entire operation. Talk about thinking outside the box.
Exactly. They saw the potential of Kafka and pushed it to its limits. For example, they had to find a way to handle those rare occasions when a message gets lost or can't be processed right away. Maybe there's a network issue or a typo in the data. Instead of letting that one hiccup bring the entire system down, they created something called a dead letter queue. It's like a special mailbox for misaddressed letters. Kafka puts those problematic messages aside so they can be dealt with later without disrupting the live data flow.
That's some clever engineering. So they've got Kafka working like a well-oiled machine, managing this constant flow of data. But how do they actually make sense of it all? That's where Apache Flink comes in, right?
Precisely. Think of Flink as the brain of the operation. It takes the raw data streaming in from Kafka and transforms it into valuable insights. For example, remember those constantly changing surge prices? That's Flink in action. It's constantly analyzing supply and demand, crunching numbers in real time to make sure those prices stay balanced.
It's like having a super-powered analyst working 24/7, crunching numbers faster than you can say fair estimate.
Exactly. And Flink's versatility is remarkable. It can handle complex calculations for things like surge pricing and fraud detection, but it can also generate those real-time business dashboards that Uber relies on to track everything from rider demand to driver availability.
So Flink is helping Uber make sense of this constant data stream. But what about those moments when they need answers instantly, like right this second? That's where Pinot enters the picture, right? I've heard it described as a super fast database designed for massive amounts of data.
That's a great way to put it. Imagine you're an Uber Eats customer and your driver hits a bit of traffic. The app updates your estimated arrival time instantly. That's Pinot at work, making sure you have the most up-to-date information, even as the situation is changing by the second.
It's like having a crystal ball that shows you exactly what's happening across the entire Uber universe at any given moment.
Exactly. And what makes Pinot even more impressive is that Uber customized it to handle upserts.
Upserts. Now, there's a word I haven't heard before. What in the world is an upsert?
It's a way to update data in real time. Let's say your driver hits unexpected traffic and your fare changes. That update, that upsert, is handled seamlessly by Pinot, ensuring you're always charged accurately, even in a dynamic situation. This wasn't a standard Pinot feature. Uber actually built it themselves to meet their specific needs.
So we've got Kafka managing this massive data influx, Flink extracting insights from it, and Pinot delivering those insights at lightning speed. It's an intricate system, that's for sure. But I'm guessing it gets even more complex, right?
You're right, there's more to explore, because sometimes Uber needs to ask bigger picture questions, the kind that go beyond those real-time insights. That's where Presto comes in.
Presto. Tell me more.
Think of Presto as the tool that lets Uber ask those complex, multi-layered questions about their data. It's like having a team of data detectives who can sift through mountains of information and uncover hidden patterns and connections.
Okay, I'm intrigued. What kind of questions are we talking about here?
Well, the research paper actually highlights a fascinating example from the Uber Eats team during the COVID-19 pandemic. They used Presto to analyze data from Pinot to help restaurants stay open safely.
Now, that's what I call using data for good. How did they do that?
They were able to analyze data on customer demand, courier availability, and even local health guidelines all in real time. This allowed them to develop strategies for things like contactless delivery and optimized kitchen staffing, ultimately helping those restaurants adapt and survive during a very challenging time.
Wow, that's incredible. It's amazing to see how this technology can be used not just for business efficiency, but also for making a real difference in the world. But I imagine that managing a system this complex on a global scale comes with its own set of challenges, right?
If absolutely. Think about it. Uber operates in cities all over the world 24 hours a day, 7 days a week. They can't just hit the pause button if something goes wrong, which is why they've created an all-active system for their most critical services.
All active. So it's like having a backup Uber system running in parallel, ready to take over if the primary one goes down.
That's the basic idea. But it's even more impressive than that. Imagine multiple identical Uber systems running simultaneously in different locations around the world. If one system experiences an issue, the others can instantly pick up the slack without riders or eaters even noticing a blip in service.
That's incredible. It's like a digital safety net, making sure those Ubers keep running no matter what. But keeping all of those systems in sync, with data flying back and forth across the globe, that has to be a logistical nightmare.
It's a massive undertaking for sure, and the approach they take depends on the specific service. For something like surge pricing, which relies on real-time data to function, they prioritize speed and availability over perfect consistency. They can't afford to wait for every single data point to be synchronized across all systems. They need to make those pricing decisions in the moment, based on the best information available.
So it's a trade-off prioritizing speed and responsiveness in situations where things are constantly in flux.
Exactly. But for things like payment processing, where accuracy is absolutely critical, they use a different approach called active-passive. In this setup, only one system handles transactions at a time, while the other stands ready as a backup. It's a bit slower, but it guarantees that every dollar and cent is accounted for. And even then, they have sophisticated systems in place to make sure those two systems are always in sync.
It's like a perfectly choreographed dance, with data flowing seamlessly between systems, making sure everything runs smoothly behind the scenes. But all of this talk about real-time data makes me wonder, what happens when they need to go back and correct something that happened in the past? Like if there was a bug that miscalculated fares or something, do they just have to live with that mistake?
Not at all. That's where the concept of backfilling comes in. Imagine needing to fix a software bug that might have impacted data from a few days ago, or maybe they're training a new machine learning model and need to feed it historical data to improve its accuracy. Backfilling allows them to essentially rewind the data stream and reprocess past events.
So they can go back in time and fix those mistakes, even though the data was originally processed in real time.
Exactly. And at Uber scale, this is no small feat. They've developed a system called Kappa Plus to handle this. Essentially, it allows them to rerun past data through their existing real-time pipelines as if it were happening live. They can test new code, correct errors, or train new models, all without impacting the live system or losing any of that valuable data.
Wow. It's amazing how much thought and engineering goes into building a system that's both incredibly complex and incredibly reliable. We've covered a lot of ground here, from Kafka managing that initial data deluge to Flink extracting insights and Pinot delivering them with lightning speed. We even talked about Presto for those bigger picture analyses and the all-active approach for ensuring constant uptime. It's clear that Uber's data infrastructure is a marvel of modern engineering. But what I find most fascinating is how this technology is being used to solve real-world problems, like helping restaurants navigate a pandemic.
It really highlights how data, when used thoughtfully and strategically, can be incredibly powerful.
Absolutely. But as with any powerful tool, there are important considerations to keep in mind. It's like we've been saying throughout this entire deep dive, with great power comes great responsibility, right? Uber's system is clearly impressive, but it also begs the question, what does it mean to have all this data about our movements, our choices, even our late-night cravings flowing through these complex systems?
It's a critical question, and one that deserves its own deep dive. As we become more reliant on these data-driven systems, transparency is paramount. How is this data being used? And what safeguards are in place to protect individual privacy? These are conversations we need to be having.
It's definitely food for thought. But for now, I think we've all had our minds thoroughly blown by the sheer scale and ingenuity of Uber's data infrastructure. Who knew that ordering a ride or a burger could involve such a complex symphony of technology?
It's a testament to the power of creative problem solving. They took existing tools like Kafka and Flink, pushed their boundaries, and even created their own solutions like Kappa Plus to meet their unique needs.
And they've managed to do all of this while building a system that feels seamless and intuitive for the end user. We don't see the complex machinery humming away behind the scenes. We just see our ride arriving on time or our food arriving hot and fresh.
It's a bit like an iceberg, isn't it? The user experience is just the tip, but beneath the surface lies this vast, intricate world of data engineering, constantly evolving and adapting to the ever-changing demands of a global service.
It really makes you appreciate the incredible work that goes into building the technologies we often take for granted. So the next time you're hailing an Uber or scrolling through Uber Eats, take a moment to think about the data flowing behind the scenes, connecting you to a ride, a meal, and a whole lot of impressive technology.
Well said. It's been a fascinating journey exploring the world of real-time data with you.
The feeling is mutual. A huge thank you to our expert for guiding us through this intricate landscape. And to our listeners, keep exploring, keep questioning, and we'll catch you next time for another deep dive.